In sections 8.1, 8.2, and 8.4, we focused on graphing quadratic equations in vertex form. We picked out the vertex, we picked out the axis of symmetry, we identified transformations, we'd create a table of values, and then we would graph our equation. So this is just a little refresher on how to do that. I have 3 different examples here for you. In the first example, I want to go ahead and pick out the transformations first. I like to go left to right in my equation. The first thing we come across is a negative sign. The negative sign causes our graph to reflect, or in other words, it will open down. It is a vertical reflection. We also have a 2. The 2, since the 2 is larger than 1, will cause my graph to stretch vertically. So we have a vertical stretch because of the 2. Remember, when our a value is negative, we have a vertical reflection. Then we also have a vertical stretch if the number is larger than 1, or a vertical shrink or compression if the number is smaller than 1. Next we have +1 inside the parentheses. +1 inside the parentheses, remember, is going to go the opposite of what we think. This will actually go to the left one. I know when we see plus, we think it's positive. It should go a positive direction, which would be right. But we've graphed these many times, and we've shown ourselves that the plus inside the parentheses actually causes our graph to move left. So my transformations, if we want to list them out over here now, we can. We had a vertical reflection. We had a vertical stretch. And we also moved our graph to the left one. Now we can also use these transformations to find our vertex and axis of symmetry. Our graph went to the left 1. So if I move left 1 on the x-axis, I'm now at -1. My graph does not move up or down at all. We do not have a transformation stating that we moved up or down. So the y value for the vertex will just stay at 0. Axis of symmetry is the equation of a vertical line that goes through the vertex. So we cannot just put a number for the axis of symmetry. We need an equation. We need the x equals. And x will equal the same value that it does at the vertex. When we go to create our table of values now to find a few other points on our graph, remember, place your vertex point at the middle. The vertex is that middle point on your graph. It's either the highest point or the lowest point, depending upon how your graph opens. Then we want to choose some numbers close to our vertex. So I'm going to choose -2 would be close to -1, and I would also choose 0. You can have your choice of putting -2 or 0 in for x. I'm going to choose 0. I think 0 is easy to work with. So we're going to substitute 0 in for x into that original equation. Keep in mind, we need to do our exponent first. 1 squared will be 1 before we do our multiplying. Also keep in mind our graph is symmetric, so if I have my vertex at the middle, these two values will be the same. If I fold my graph in half, those two values need to match. So let's go ahead and graph. We have -1, 0, 0, -2, and -2, -2. Our axis of symmetry is that vertical line right through the middle. Go ahead and make our parabola, that U shape. So with this first example, we've reviewed vertical reflection, vertical stretch, and moving our graph left 1. Let's move on to example 2 and see if we have a few other transformations to look at. In example 2, the first thing I come across is a 1/2 times my x squared. 1/2 is less than 1, so this is going to cause a vertical shrink, or you can also use the word compression if you would like. The -3 is outside the parentheses, so this will cause our graph to move down 3. So transformations, we have a vertical shrink or a compression, however you'd like to state that, shrink or compression. And then our graph also moved down 3. Again, from these transformations, we can find our vertex. Our graph does not move left or right at all, so the x value for the vertex will remain at 0. Our graph does move vertically. Our graph moves down 3, so the y value will be a -3. Axis of symmetry, again, it has to be the equation of a vertical line, so we do need the x equals. And x will equal the same value that it does at the vertex. When we go to find a few other points, we want to complete our table. Put your vertex point at the middle. Pick some values close to 0. I'm going to pick -1 and +1. Substitute in either value you would like. I'm going to stick with the +1. Again, I cannot stress this enough. We need to make sure we do our exponent before we multiply. 1 squared is 1. So we end up with 1/2 minus 3. We get -2.5. And if you want to put the decimal 2.5, you sure can. So when we go to graph, we have 0, -3, -1, -2.5, +1, -2.5. And it's okay when you go to graph the half, we just go down 2 and then half of a box. Again, the axis of symmetry should split my graph in half. If I were to fold my graph along that line, the two sides should match. If they don't match up, your graph is not symmetric, and you might have made a mistake somewhere finding a value in your table. So far we have reviewed vertical reflection, vertical stretch, moving left, vertical shrink or compression, and moving down 3. Let's do one final example where we put all these things together. Let's start by picking out our transformations. The first thing we come across is a negative sign. The negative sign is going to cause our vertical reflection. And then there's also a 3 with it. The 3 is larger than 1, so that's going to cause a vertical stretch. We look inside the parentheses and we see a -2. Subtracting inside the parentheses, again, this is something we have graphed many times, we've shown ourselves many times. It actually moves our graph to the right 2. Last but not least, the +4 on the end will move our graph up 4. From these transformations, we can find our vertex. We move right 2. So if I move right 2 on the x-axis, that's a +2. And if I go up 4, that's a +4 on the y-axis. Right 2, up 4. The axis of symmetry, again, is that vertical line. We need the x equals, and it will equal the same value that x does at the vertex. Axis of symmetry goes right through the middle of our graph. To find a few more points on our graph, we put our vertex at the middle of our table, and we pick some values that are close to 2. Close to 2, I would pick 3, and I would pick 1. It's your choice which value you put into the original equation to find the y. Since your graph is symmetric, these two values will match. I'm going to choose to use 3. We do what's inside the parentheses first. Then we do our exponent next. That's the part we really have to be careful on. So we end up when x is 3, y is 1. So when x is 1, y will also be 1. So let's go ahead and graph 1, 1, and 3, 1. And we get our nice U-shaped parabola.